Welcome. Today we're going to combine the product rule for exponents, the division rule for exponents, and negative exponents. Now, if you're comfortable with adding and subtracting positive and negative integers, this lesson shouldn't be that difficult. If you have two bases that are the same that you're multiplying together with exponents, we obviously add the exponents. Just be careful if one exponent is negative and one is positive. When we add them, we actually add a negative 5 to the 8. We would get 821 to the third power. So again, they're using large bases in order, so we don't want to multiply it out. We just want to represent the expression as a base raised to an exponent. Here, again, the division rule, if I have 245 raised to the third power divided by 245 raised to the negative 2 power, we still subtract the bottom one from the top one, but we're subtracting a negative. In other words, it's going to still be a base of 245 where I have that 3 minus that negative 2 on the bottom. And what happens when we minus a negative? We end up adding a positive, and so we get 245 to the fifth power. Now, there are times where we end up with the exponential expression on the bottom of a fraction because we don't want negative exponents. We, at this point, like to simplify our expressions down to a positive. So here, if I was to do negative 7 minus the 5, I'd get a 59 to the negative 12th. But that's not the way we like to write our exponential expression. We don't like this negative exponent. So we just got to remember to bring that down underneath a 1 and write it as 59 to the positive 12th. I actually like to think of it this way. If this top exponent is negative, then I'm actually going to subtract the top exponent from the bottom exponent, which is perfectly fine, doing 1 over 59 to the 5 minus the minus 7, 5 minus the minus 7, keeping it in the denominator, and then I have that positive exponent of 12 that I wanted, just like I did this one. But you could do it either way. You could subtract the bottom from the top and get a negative exponent and then bring it down. And we're eventually going to get to a combination of all these things where we have to combine a lot of expressions. I would recommend that if you get lost easily in the process is ignore the denominator for the first part. Let's just ignore the denominator and combine the numerator. So if I have 138 to the negative 1, 138 to the negative 2, and 138 to the negative 5, I'm going to add those three negative integers together, and I'm adding them. So negative 1 and negative 2 add up to negative 3, and negative 5 more gives us a 138 to the negative 8 power on the top of our fraction at the moment. Now I'm going to ignore the top and look at just the bottom and combine these two. Well, I have 138 to the negative 3, and I have 138 to the positive 7. So negative 3 plus 7 is 4, so I have 138 to the fourth power. Now I'm back down to just single two terms, single division one, where I want to keep the exponent positive. So I'm actually going to bring this one down, making it positive. So I'm going to add a positive 8 to 4 and get a 138 to the 12th power on the bottom, and we leave a 1 on the top. Again, if you had accidentally did 138 and did the negative 8 minus the 4, so the top minus the bottom, you would have had 138 to the negative 12th, and then you would have just needed to say, oh, I don't want that negative exponent, so what do? I bring it down to the bottom of a fraction, changing it to a positive exponent, and then leave a 1 on top, which is the exact answer I got up here. So hopefully this is just almost a review, because we've talked both about the product rule, the division rule, and negative exponents. It's just combining them all. If you have questions, please bring them to class.